hear me at home and see me, or at least see the presentation out. Here. Okay, so before we jump into today, couple of things. Okay, so we have 1 week left. Yay. You should be getting another note packet for Thursday/Friday. They have it here in class. And I mentioned something above. Let me know if you need it for pickup, or if you need somebody to, or if you need it, just have somebody drop it off. I can even try mailing it if you're at home. Just let me know. Or if you want somebody to take it with you, also let me know. You're going to be here tomorrow. You'll be in person to get it. So you don't need it until Thursday. Let's see what else. I think that about covers it. Monday. Let's talk about Monday, Tuesday next week. So Monday, Tuesday next week. It's next week. We are going to do 2 things. We're going to do a unit circle. Kind of crash course and assessments. And we're going to do an EMPT. So let me clarify this. On Monday, we'll do the crash course, and Tuesday we'll do the EMPT. This is the UW system math placement. Practice test. Okay. With the ACT being sidelined, like a lot of colleges aren't requiring you to do an ACT. I think math placement tests that colleges have you take at the beginning, like in the summer, or in the spring, are going to become really important. So the UW system has 1 single math placement test for the whole system. So we're going to show you what that looks like in practice form on Tuesday. Just so that you have a little exposure to that. Okay, so onward. Okay, so today we are doing day 9. No, we're doing day 8 today. Yes. Yeah, we're supposed to be doing day 8. Sorry about that. I'm ahead of myself here. That's done. Okay, day 8 today. Okay. So we do 8, 9, 10. Yeah, that's right. Okay. Okay, so day 8 involves a short clip on concavity and drawing the connections. Here we go. Oh, I need to share this, don't I now? Okay. Lost that share capability. Oh, come on. Here we go. Does that work? Can you see that at home? Okay, thank you. Just not showing up like it usually tells me I'm sharing the screen and then not anywhere. Interesting. Okay, so takeaways from the notes here. So concavity is what gives our functions their shape, their curvature. And so we think about the scenarios of concave up and concave down. Concave up looks like this. I say it looks like a cup or a smile, but cups rhymes with up, so that's kind of nice. So concave up looks like a cup. Kind of tends to look like something that would hold water. And then concave down, that looks like a frown. That kind of rhymes, which is nice. But concave down looks like something that water would spill out of. And so we can also have halvesies, so to speak, like something that looks like this is still concave up. It's like half a smile, and something that looks like this is concave down. It's like half of a frown or half of a something that would spill water. So just kind of keep that in mind. So in terms of justifications, because we're really getting into explaining our reasoning or justifying our reasoning, and that all goes back to looking at the values of the first and the second derivative. So in this situation, justifications require a statement of connection, okay, between concavity and increasing and or decreasing nature of f prime of x. So we know concavity is the second derivative. And so the second derivative is watching the first derivative change. That makes sense? Kind of like the first derivative is watching the function change, it's the rate of change. So the second derivative is that rate of change of a rate of change. So it's watching that tangent line either get more vertical or watching that tangent line get more horizontal. So that's what the second derivative is. So we can connect concavity to the increasing or decreasing nature of f prime, or we can connect concavity to the sign of the second derivative f double prime. Because if f prime is increasing, we know increasing functions have derivatives that are positive. So this is the derivative of that first derivative. So increasing first derivative would be positive second derivative. Decreasing first derivative would be negative second derivative. Points of inflection, I call them POIs. They require a statement of connection between the second derivative being 0 and, I should make this a big and, the second derivative changing in sign. So that's where that sign chart becomes important again. Making a sign chart for the second derivative, and this is where it becomes really important to label those sign charts. I know I was talking to some people last week about labeling it f prime. Now this week I'm going to be getting on you about labeling it f double prime, because we've got two sign charts, and this is why it's important to label them. So it's been a similar process. We're going to find points of inflection, and then we're going to look on either side of those points of inflection, make sure we're changing from plus to minus and minus to plus. If we don't change, no point of inflection. And then points of inflection are extreme rates of change. So think about this. If f double prime is 0, then f prime must have a hill or a valley. Okay, because f double prime is a derivative of f prime. So that's why we say those are extreme rates of change, because those are hills and valleys on f prime. So those are the big takeaways. Any questions about kind of that summary? Okay, so to summarize then, more in fashion, how is concavity related to the second derivative? We know that concavity is either positive when we're concave up or negative if we're concave down. So that's the direct relationship for the second derivative. And of course, the only, there's another, there we go. The only other alternative, if it's not positive or it's not negative, then it's 0. And we know that that is a possible point of inflection, but it will only be a point of inflection if we have that sign change. Okay. So you should be writing that down into your summary. Yet, how is concavity related to the second derivative? Okay, so you have some free response topic questions and some multiple choice topic questions in College Board. The free response are pencil and paper. Just do A and B. I know you have A, B, C, and D, but C and D are really more relative to what we're doing tomorrow. So just A and B of those free response, and then jump into con and not con, excuse me, jump into College Board and do the topic questions from day 8. And then in preparation for tomorrow, we've got day 9 notes and these cons on concavity. So at this point, I'm going to stop the recording, but we can hear you here in the classroom. So we'll be able to answer any questions you might have if you have any from home.